How's it going, everybody? And welcome to another installment of Tech Support Thursday. So, a little late to the game. It's been a busy week and stuff like that. I'm going to answer some of the questions that our friend J.K. Rowell has posted here. But I did want to get to this question that was posted a few hours ago. And the comment was, "Hello, Rob. Will you consider to create some network content which is not bounded to specific certification like NA/NPIE? I'll try to explain what I mean. There are a lot of certification related content out there, which I really like Cisco certification. While I really like Cisco certification, but for me, it always felt a little bit disconnected from the real life, even though Cisco certification is really best in networking industry. I think it would be really great if you make some course about real life corporate networks. For example, some complex topologies, not only with routers and switches, but also firewalls and load balancers. For example, I don't know where a load balancer should fit into network and etc. So you can create such course with videos, several complex Eve topologies, workbooks, and of course, I'm not asking you to create such content for free. I'm willing to pay for such content, and I'm sure many people will be interested as well. Most of the technical content creators are focusing on certifications, and if you do such content, you will stand out." And I completely agree with you. And that is something that I've always tried to do that is different than everybody else, because there's probably 30 different content creators out there that do network training. And you're absolutely right. If everybody does the same thing, you just kind of get lost in the minutia. You get lost in the noise. So you're right. That is something I'm actually working on, and it's one of those things where I would love to be able to take multiple different technologies and capabilities and just kind of all mash them together and make it all work. That will be coming. I have a game plan. It'll be similar to what we saw in the big enterprise video series that I was working on. And I was going to call it real world networking. And I do something that was geared towards, okay, if you have this particular situation, it's not going to be like certification focused. There will be topology here, assuming that you're already at a certain level. And then we're like, okay, here's a change window we're going to go through and how you would go about doing that. It's time consuming. So, but yeah, I do agree with you 100% on that. And the other comment here was, your content will be valuable for years and years. Really fits the getting back into networking crowd, especially. I appreciate that, and I totally agree. So let's jump down here to the other questions that came in. And all right, so let's get to our first one of one or two maybe we'll get into, because I don't want this to be like an hour long TST. Something I don't quite understand here. Isn't the point of having layer 3 MPLS by using multi-protocol BGP, BRFs with route distinguishers and route targets, LDP, RSVP to create a BGP-free ISP core? And isn't the ISP core supposed to be an IGP like ISIS or OSPF running, right? Then why do we use iBGP route reflector in the core? If we're going to use BGP in the core to begin with, then what's the point of using layer 3 MPLS, and where is the core free? Okay. Funny enough, this is a common misunderstanding, or I'm not exactly sure what to coin it per se, but this is a common thing that I see in the industry. Now, is it wrong? No, you're not wrong for thinking this. So, since I work for a service provider, I feel kind of uniquely qualified to answer this question, because I understand how our core is built. I have access to a lot of really smart people that, if I have questions about the way something is built, all I have to do is ask them, and oftentimes they hop on a call with me and they walk me through it. And so I'm like, oh, okay, cool. So even though I've got a certification, the top, I've got the IE, that doesn't mean I know everything. So let's get down to brass tacks about this. So we're going to pretend like you don't have any understanding of how this works, because I've I think I've tried to answer this question in the past, and it's like, I don't, maybe you're just, it doesn't click with you. That's okay if it doesn't. I'm not trying to pick on you in that respect. There's certain technologies that just elude us, and excuse me, no matter how hard you try, it just you can't get two and one and one to equal two, right? So let's first of all, before I get into anything about uh, the ISP, let's understand that there's let's we'll try to think of the best way to respond to this question. So think of think of it from two different perspectives. The first perspective is you have just a regular BGP set of routers. IGP is working, and you have all the point to point, the /31s between all the devices configured. Each device has the loopback address as the /32 host route, and you're running some sort of IGP. For the sake of argument, we're going to pretend like RIP and EIGRP don't exist, because in the service provider world and in the data center world, they don't. You're not going to see them in those worlds, because they just don't scale or work the same way that IS to IS and OSPF do. Now, I'm a fan of IS to IS. I've actually started working with it a lot more than I have OSPF, and in my opinion, it's better than OSPF. It's in my opinion, provides more scalability. You deal with levels versus areas, and so yeah. Anyway, so what you're describing here in the first bullet, I'll probably go down them in order. What I don't understand is isn't the point of having layer 3 MPLS by using MPBGP, VRFs, LDP, RSVP is to create a BGP free core, for a free ISP core? No. So let's try to understand what the point of layer 3 MPLS VPNs. What is the point of that? Versus what is the point of having a set of routers that you run an IGP on, you set a BGP on, you do a full mesh of peerings, and then you bring customer circuits to the edge, and then the traffic flows through your backbone into, or wherever it's got to go, to the other customer site, to somewhere on the internet. Two different things. What really ends up happening here is how next-hop processing works in iBGP. That really, when you get it all the way down to boil it down to the main pieces that really differentiate between the two, is how next-hop processing works. So, but you also have to think of BGP. What are the two rules in BGP that you have to meet in order for iBGP to work correctly? So pretend like I just paused the video, or I'm going to give you like the Jeopardy theme song countdown. I'll give you 30 seconds to think about it. What are the two things that you need to think about? So cue the Jeopardy final question theme music. The do 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 do, right? First one is full mesh connectivity, right? So you have either you connect all of your devices to each other through physical connectivity, or you connect them in some way where their loopback addresses are all reachable from each other. Either way is fine. There's no right way or wrong way in that respect. But now you take it a step further, and then you're running BGP between all these devices. Well, if you're not doing anything MPLS, do you need a VRF? No. Do you need LDP? No. Because you have IGP providing the reachability for BGP. I think the one thing that stands out is that BGP and IGP, like OSPF, BGP is not a routing protocol. Wait, what? BGP is a reachability protocol. That's what its job is to do. The moment you inject iBGP into any autonomous system or a series of routers, you automatically change the behavior of how the traffic will be forwarded through the backbone. if you don't take into consideration next hop processing and that IBGP doesn't change the next hop, that you either need to be fully meshed, so I connect to everybody else, or I use route reflection, you need to have some sort of way in there to make IBGP work the way you would expect it to. Now, when you take a look at these things, if you don't have an LDP in place, and I was to try to get a series of routers that are connected to each other be able to send the next hop appropriately, how do you do that? Because what's the rule of eBGP? The rule of eBGP is you change the next hop. Whoever you're peering to, that is the next hop IP. You automatically change the next hop in your update to whoever you're peered to. IBGP doesn't do that. So you need to go to your perimeter, your PE device, and you either need, because the core is not going to know how to get there, and the ingress router is not going to know how to get there, because he doesn't know how to get to this next hop IP address. In his local routing table, that IP address is not there. So you need to do one of two different things. You either need to enable IGP on the link that's connecting to that on that eBGP peering, so that subnet needs to get advertised into IGP so that that router, the ingress router, knows how to get there. Or you go to the egress PE and you do a next hop self. You say, you know what? I have this eBGP peering to this other router. I'm learning this prefix in. I'm advertising it to. But you won't inject it into your BGP table because you don't know how to get to the next hop. Well, instead of you using the next hop that I sent you, I want you to use me as the next hop. I know how to get there, so use me as a proxy. So point yourself to me, and then I will get you to where you've got to go because I already know how to get there. Think of it like a Type 3 LSA in OSPF. Your area border router is going to know how to get to all the Type 1 LSAs in both areas. Where if you have a backbone or a non-backbone area, let's say like area 1, you have an internal router, he's going to see all Type 1 LSAs for his area because that's what Type 1 LSAs are for, but he's going to see Type 3 LSAs or OSPF inter-area routes in the routing table because those are Type 3 LSAs or network summaries. So he's going to go to the area border router as his gateway to get to somewhere else. Topology summarization. So the idea here is when you're dealing with non-LDP forwarding, straight IGP, the next hop processing piece has to be solved first, which means you have to set next hop self or advertise the eBGP peering subnet into IGP so that the ingress PE knows how to get to where you're at. That's the first thing that you need to have locked into place. Now, your other question here, isn't the ISP core supposed to be an IGP, like ISIS or OSPF? It is, and just about every service provider that I know of runs IS-IS or OSPF, more often than not IS-IS. Then why do we use an IBGP route reflector in the core? If we're going to use BGP in the core to begin with, then what's the point of using L3 MPLS, and where is the core free? So it's a colloquial term when they say a free core. It's not totally free. It is mostly free, meaning that especially when you're talking about MPLS layer 3 VPNs, what ends up happening is you are going to enable IGP because you need an IGP in order for LDP propagation to work, and with RSVP. So if you're going to use RSVP to do your MPLS traffic engineering, so you can do bandwidth reservations and things like that, there's extensions inside of IGP that you have to turn on in order for traffic engineering to work. So regardless of the situation, you need an IGP to do that. You can't just willy-nilly throw LDP at it and expect things just to magically work. It doesn't work that way. So what you end up doing is you turn on LDP, you turn IGP on, and then they automatically form LDP peerings. When you do that, your next hop processing is now sufficient because now you're sourcing the traffic from a loopback address. Because your BGP next hop is going to be the update source loopback 0 when you do your route reflector connectivity. The free core concept, not the default free zone, meaning you don't see a default route in the routing table. That's two separate things. When you see the term free core, BGP free core, that means that the provider core routers, those routers themselves, are not running BGP. The only routers running BGP are your route reflectors. You need some way. Well, so I'll play devil's advocate and say, let's say you have 500 routers on your perimeter edge, your provider edge router, provider edge ring that connect to your customer sites. And let's say, for the sake of argument, that you don't want to run any BGP in the core. But what do you need in the core? In order for this to work, you need to do what? You need to have an IGP like IS to IS, and you need to have LDP enabled, or RSVP if you want to get fancy and do bandwidth reservations and fast reroute and things like of that type. Well, in those particular situations, can you go on a particular the first of 500 provider edge routers and then form 499 other IBGP peerings with every other router? You sure can. So let's actually do the math on that real quick. If I was to do that, calculator, right? Let's do some very simple math here. Let's say I'll take a high number because that's essentially what some service providers do. We'll take 500, so it's n times n minus 1. So you have 500 total routers, and then you say times 499 because you're peering to 400. So there's 500 routers, but you can't form a peering to yourself. So n times n minus 1. So it's 500 times 499. That's 249,000 BGP peerings. Then you divide that by 2. So it's n times n minus 1 over 2. So you got to cut that in half. By 2, 125,000 peerings. Well, that's a lot of peerings. So now add another router. Now you're at 501. 501 in your core times 500. Now you're at 250,000. So as you start to scale this up and you start looking at the connectivity, it doesn't make a lot of sense to form a full mesh of IBGP peerings. That would answer the you need to do that would remove BGP completely from your core. If you wanted to run a true BGP free core, you don't do any route reflection. Now here's the problem with that. That's a lot of peerings. I would suspect that's probably what's the average BGP peering? So let's do some math on this real quick. If you have your remote AS command, that's one. You have your update source, that's the second command. You're probably going to do authentication, that's the third command. That's 3 to begin with. Now let's take into consideration there might be other capabilities. So let's just do 3 at a minimum. So you take 3 times, and that's not doing anything fancy, right? We're not going in there and doing any type of add path or any other cool capability. So you got 3 times, and we're going to do 250,000 connections. That's 750,000 lines of configuration per router. So now we have a scenario where we've achieved our BGP default. BGP free core, right? So we've gotten you design wise where you want to be. Now I have to dump almost 1 million. Well, it's probably going to be more than that. It's probably going to be closer to 51 or 52,000, 751 or 2,000 lines of config per provider edge. So I don't know a single provider that's not doing route reflection. It just makes more sense. So you get a full copy of your table from everybody else. Now this is where it becomes a resource issue. What happens when you get 250,000 copies of the same routing table? Any ideas? That's not 1 or 2 copies. That's 250,000 copies. Because you have to think about it. If you're peering That's how many peerings you have up, right? So when you start scaling to those numbers, what's going to end up happening? You're going to crash the device. I don't know any router that's able to support that many freaking peerings. That's a lot of peerings. So what providers do to try to optimize this design and make it easy to deploy your configuration is they are going to leverage route reflection. Why do you use route reflection? This is an architecture answer, not an engineering answer. Why would you do that? Well, I'm an architect, and I have a junior engineer, not picking on you saying you're junior, but I have a junior engineer come to me and say, hey, why are we doing this? Because curiosity killed the cat. I'm like, okay, I'll bite. Why are we doing that? Well, because if I am going to scale out my network, I want to make it so that if I need to add additional provider edge routers, I'm doing it in such a way that my deployment time frame is as small as it possibly can be. So if I have 750,000 lines of config on my box, it's probably going to be closer to 755,000, 760,000, depending on how many like access lists and other stuff that can potentially go into play there. So that's just lines of configuration needed in order to get BGP online. That's a lot of config. So when you get into situations like that, these are the things you need to be paying attention to. So what do I do in order to try to make the deployment easy? Let's say I have 4 route reflectors. Well, that's just going to be 4 peerings. Now I go from having 250,000 to 4 times 3. I've got 12 lines of config for BGP. All I got to do is copy this small text box of config, copy and paste it into the router, make sure that IGP is working, LDP is turned on, the peerings to it from the core come online. As long as all those things are there, IGP set up, I go from 12 lines of config for BGP, probably another 10, 12 lines for IGP and LDP. Let's say I'm at 25 lines of config. 25 lines of config to stand up a new router that's repeatable over and over. I can basically have the same configuration. If it's IS to IS, obviously my net address, my network entity title changes. But when you start getting into large-scale service provider backbones, these are the reasons why they do what they do. So is the core free? No, it is not completely free. It is mostly free. And you have a small subset of devices, typically out of band. Typically you're going to be deploying, for example, I was just talking to some engineers the other day about this and how they are looking at, they roll out dedicated servers for BGP route reflection. So these are virtual machines running in a data center. That is what's controlling the route reflection for different parts of the network. It's a virtual machine for with BGP because it doesn't make sense to have a dedicated router that costs tens of thousands of dollars, if not hundreds of thousands of dollars, to sit in a data center doing one thing and one thing only, maintaining BGP state. Now that box is going to have a million lines of config on it to maintain all of these peerings. And he's going to do it all day long. So when you look at the scale, these are the things you have to take into consideration. So why do we use iBGP route reflection in the core? Because from a configuration scalability and resource utilization on the device, it makes sense. It doesn't make sense to do full mesh iBGP. Can you do it? You can. But now you're dumping north of 750,000 lines of config on a per box basis. That doesn't make sense to me at all. When I was introduced to the concept of route reflection, it was like, wow, I'm glad somebody thought of that. These are some things you just got to have at the back of your mind when you're talking about connectivity. So I hope that answers your question. You're not wrong in asking. And this is a question that I asked a lot when I first got in the industry too. Like, why do we need this? And if you don't ask those questions now, you're not going to ask them later. So I'd rather you ask them and me give you a direct answer, whether you necessarily like the design. But the thing that you have to think about when it comes to the design is you're trying to solve a problem. What is the problem? Configurations and scale. Put yourself in the shoes of the guy that's got to do the work. Would you really want to have to go through and update I don't even want to know what a 750,000 line notepad doc is going to look like. How long that thing is going to take to load. What the amount of memory it's going to take to load up all that text. And then, God forbid, you screw something up. You know what I mean? Maybe they don't even do that. I don't know. Like, I don't work in operations. So, just some food for thought when it comes down to how this stuff works in the real world. But your BGP free core is going to be minimal BGP. Only the devices that need to be running BGP will run BGP. Everything else will be using IGP. Because if you think about an MPLS Layer 3 VPN, if you ever look in the provider core doesn't know anything about what the customer's got going on. It knows what IGP is going on. It knows where the labels are going. But other than that, it has no idea what's happening for the customer. And that's the point. You're trying to provide a seamless connection. And I'll be honest with you, regardless of which address family you go with, IPv4 MDT, IPv4 MVPN, L2VPN, EVPN, they all support route reflection. And why do they support it? Because it makes sense on a large scale to have all of your stuff centralized, and then you can add in. Do you lose visibility? Yes. One of the drawbacks to doing with route reflection is you only get the best route that the route reflector advertises you. That is why things like BGP PIC, prefix independent convergence, and AdPath were added to the mix, and so you get ECMP connectivity in place so that you can have an add path, an install path, and a backup path in order for all this stuff to work. That is why that stuff is there. Yeah, if you have more questions on that type of stuff, feel free to keep dropping comments and things like that. I don't want to discourage you, but I want to give you like a real world explanation as to why things are done the way that they're done. They're not just done because they seem silly. That's not how network engineering works. So that took 27 minutes. So I kind of was going to go ahead and tackle this one because it was kind of a loaded question and it needed some kind of a breakdown to it. So I'm going to leave this one here, and then I'm going to leave some of these other questions in here. There's quite a few here that are really good questions, and I will have no problem answering them. But for right now, I'm going to stay with this one for right now. Again, if anybody has any questions, comments, concerns, feedback on any of that type of stuff, and you want me to dig deeper, feel free to do so. So, in the description below, you'll see a link to the Patreon for if you can't join the channel membership through the channel or through YouTube, there will be a link to Patreon for you to go that way. There will be a link to the sample workbook, and there will be a link to the Patreon to buy the Enterprise workbook and things like that. I am currently working on rebuilding a website that I ran a long time ago so that I can centralize all that stuff together. So that is in the works. I'm actually looking at it right now. It is just one of those things where it's going to take some time to get figured out and all that good stuff that goes along with it. So I'm interested in seeing what this is, how it's all going to pan out. So anyway, with that being said, how's it looking? Ooh, there might be a problem. I might have to. Anyway, I'm going to worry about the issues that I'm running into with the website and get all that stuff squared away. So if you guys have any questions, comments, concerns, feedback, please let me know in the comment section below. Don't forget that Friday, the 29th, which will be tomorrow, I'll be going live on YouTube for about an hour for members only. If you are not a member of the channel but you want to become a member, you can join either through the channel or jump on the Patreon, $10 a month, and you get 4 Fridays a month. This will be our third one, and I'm trying to do this on a regular basis, and go from there. So, and there was a question that was posted to me the other day that I'm going to take a minute and just answer, about why I'm no longer going to be putting entire like certification based video courses on YouTube. And it's a good question, so I figured I'd answer it. And the reason why I'm not doing that anymore is because the viewership on those videos is it's pretty low. And for someone that puts a lot of time and effort into producing the content, and then going through editing, and then uploading the videos to YouTube and that type of stuff. Yes, I'm aware that I upload in big batches and I release on a regular basis, or at least I was, but I was using that kind of as a sanity check, and the viewership on those videos was really, really low. Now, I know YouTube is not the correct platform for this type of that type of content, because the audience isn't typically looking for that. So what I'm going to be doing instead is I'm actually looking at producing much more entry level stuff on YouTube, where it'll be much more palatable to those just getting started or getting back into it, and it'll be more like CCNA and lower focus. I might even do like a CompTIA Network Plus type of deal, because those type of people will be looking for that content. Where if we have somebody like J.K. Rowell or or Salim, or you take your pick, right? The Rawi, these folks are going to be looking for more direct training that you'd be probably willing to pay a monthly subscription fee that's reasonably priced to access the content. That's my suspicion. So when we take a look at how that comes into play, that's the direction I'm deciding to go. So YouTube will stay. I'm going to do the Whiteboard Wednesday. I'm going to do the coaching session Fridays. I'll do the tech support Thursdays. All that good stuff that goes along with it. But my intention is to take the certification focused long form videos. I'm taking them off YouTube. Whatever's there is going to stay. But whatever was going to be in the pipeline to get released, that is going to get put on this website once I have an opportunity to get it built out and put it together, because that makes more sense to me. And the workbooks will get pulled over here as well. So it's going to be one of those things. It's going to take some time, and I'm just going to ask y'all to be patient. But it's one of those things where, as you're going along, these are going to be things that are hopefully going to make more sense. So with that being said, I want to thank you guys for stopping by and hanging out with me. I appreciate the support, and I will catch all of you people in the next video. Have a good one, everybody.